Now we move to the fixed time period model. Okay, so actually for the fixed time period model, it's a little bit easier. Okay, it's a little bit easier. So fixed time period model. Okay, all you need to do basically is to calculate the order quantity. Okay, order quantity. Normally we will tell you what is the preset up review period. Okay, normally in a context we'll tell you, okay, based on the management experience for this specific type of the product, they may review the your inventory level every month or every week or even every 2 months. Okay, that's all normally will be given by the context. All right, now, but for the quantity amount, remember, in the fixed time period model, okay, we know that the time period itself is fixed, right? So normally you will only count your inventory probably at the end of every week or at end of every month. That depends on the decision about your review period. Okay, so if your review period is 1 month, then basically you will only count your inventory level at the end of every month. That's it. All right. So, but we say that there's one thing is flexible within the fixed time period model. Okay, it means that basically each time when you reach the review period, okay, when you look at your current inventory, okay, you need to decide the new amount that you want to order from your factory. Okay, from your factory. Okay, so how to decide how many order amounts that we need to order is actually depending on this equation. Okay, remember in the fixed time period model, the order quantity amount is flexible. It's not fixed. Okay, it's not fixed. In the fixed order quantity model, that is fixed, but here it's not fixed. Then we have to basically at every review period, you need to decide the specific quantity amount. Okay, you need to decide that amount. All right. So here I already list this amount, the equation. All right, I list this equation. Okay, it won't be very hard. All right, but you see that this equation is of course it's different from what we just mentioned within the fixed order quantity model. All right, but you see that when we talk about the time within this equation, okay, the time itself is not t or l itself, is t plus l. All right. So before actually we even start to talk about the specific meaning, all right, within this whole equation, okay, let's first look at a few different notations. So Q definitely would be the order amount that you want to order, all right, within the review within a review period, all right. D bar still the average daily demand, okay, the average daily demand. What is T? T represents your review window, all right. Your review window. What means by review window? Okay, it's basically the number of days between the reviews. Okay, if I decide to review my inventory every month, what is the number of days? Normally it would be 30 or 31 days. Okay, we can simply assume 30 days. Okay, that's good enough. All right, so T would be the number of days between reviews. What is the L? Remember, we actually talked about L in the fixed order quantity model, right? So L represents basically the number of days you will transit. Okay, the new order will transit from the factory back to your retail store. So we call it lead time in days. All right, and these still basically is decided by your probability of not stocking out, right? The probability of not stocking out. All right, so if you decide 95% of chance that you want to run, probability of stocking out, then the corresponding z can be easily calculated, right? Or it's 98%, 99%. It's very, very easy to calculate. Just check your z table. That's it. All right. The detailed procedure of checking z value already mentioned a few different times within, no matter this video and also the last video. All right. So just look at those specific points. All right. And then this would be sigma. All right. Sigma itself, we know that. You see, in the example 11.4, we know that the sigma d is separate, right? I may tell you sigma d, but you need to further calculate what is the sigma t plus L, all right? And the I, in the end, basically the inventory on hand, your current inventory on your hand, all right? So this is the equation that we need in order to calculate the order quantity within each review period. Okay, within each review period. Okay, but conceptually, all right, you may have the question, why here when we talk about the time, you see, no matter it's t or l, it's about time, right? We are not using t. We are also not using l. We are using t plus l. What's the reasoning behind? Think about this. What is the reasoning why, when we talk about the time in the fixed time period model, we're not directly using t, or we're not directly just using l. We are using t plus l. Okay? The reason is very simple. Remember that we don't actually count your inventory between two review periods, right? Between the two review periods, we don't actually count your inventory. All right? And also, besides that, even if you review it, you reorder some point, okay, you reorder some new stuff from your factory. You also need some time for those new stuff to from your factory back to your retail store, okay? So you see that actually you are facing the risk of stocking out, okay, in both situations, okay, between two review periods, okay. For those days, you may have the situation of back order, right? And also, even if you order some new amount, you still are facing some uncertainty within those lead days, right? Basically, for those days that you reorder some amount, but it doesn't come to your retail store because it's in transition. So in order to mitigate all the uncertainty, all the risk of running out, okay, in no matter the days between review period or in the transition period, okay, you have to consider all those times. Okay, you have to consider all those times. That's why here we are using t plus l instead of t or l, because you are trying to get rid of the probability of running out in both periods. That's why you use t plus l. That's why d bar times t plus l and plus d also sigma t plus l, okay, minus I. That's why here the equation is exactly shown here. Okay, now let's. This is just a graph illustration. Please look at this. Okay, it should be very vivid. All right, but the key sense is already illustrated. All right, now here, this is the corresponding example 11.5. I already captured the key points within that example. If you are interested about the specific context, all right, go back to look at the textbook. All right, now. If I assume that the daily demand is following a normal distribution, okay, still we're following a normal distribution, and if the daily demand is the mean demand is 10 units, okay, if I tell you that the mean demand is 10 units, and if I tell you that the standard deviation is 3 units, you see d bar and sigma d, okay, or it's already given you, all right, and since this is following normal distribution, and if I tell you both d bar and sigma d, you know everything about this normal distribution. Okay, you already can capture everything about this normal distribution. That's good. Okay, now if I assume that the review period is 30 days, means that okay, let's say at the end of August, I review the inventory, and then until the end of September, I will review it again. Otherwise, between these two review period, actually I won't count the inventory. So the review period here is 30 days. All right, let's say we already know that. And let's say if the lead time is 14 days, okay, it's 14 days. Basically, each time if you order a new order, okay, then it will take 14 days before it will reach to your retail store. Okay, it's a little bit long, but it may also happen, right? And suppose that we try to make sure that we have 98% of chance that the market demand will be met from the stock. Okay, 98% of chance. So basically, the running, the stock out chance is only 2%. All right. So suppose that, okay, today when you look at your inventory, you currently have 150 units in your hand. All right. Now, suppose, okay, today is the end of September. Okay. Suppose today is at the end of September. You need to decide how many amount, okay, you want to renew, okay, for the next period. Okay, so you have to decide that. So the equation is already shown from the last slides, which is d bar times t plus L plus d times the sigma t plus L minus I. Okay, what is d bar? Very simple. The mu, right? The d bar is 10, right? Okay, and what is t? T is basically review period, which is 30 days. Okay, and what is L? L is basically 14 days. So you just plug in these numbers. Okay, here I need to emphasize that sometimes I may not actually give you, I may not let you know that the review period is 30 days. I may say review period is 1 month. Okay, you need to transform back to days before you use T plus L, right? Because you need to make sure that the units for the review period and the lead time is the same unit. Okay, you cannot use 1 month plus 14 days. That's not making sense, right? You need to use how many days plus how many days. It looks simple, but sometimes people may have this kind of mistake. All right. So 10 times 30 plus 14 and plus z. All right. How to get this d? You want to have the 98% chance that you want to stock out, right? So you go back to the z table, look at the which number which is most nearly around 0.98, and look at the corresponding row and the column, and in order to make sure that the corresponding value, right? Let me show you. Here, 0.98, right? If you look at 0.98, it should be this one, or even this one is closer. You see, this is 2.0. You see, this is 0.9798, right? This is close enough to 0.98, right? If you look at the corresponding row and column, it should correspond to 2.05. So that's why here I think it should be 2.05. All right. You see, 2.05. So 2.05 times the sigma t plus L. The equation for sigma t plus L is exactly showing here. Okay. You see, since we are talking about the length of t plus L, that's why under the square root, you use t plus L, okay, times the square d, times the sigma d square, okay, times the sigma d square. Sigma is 3, so that's the 3 square, okay, and t is what? 30. L is what? 14. So 30 plus 14 times 3 square, okay. Here I want to emphasize. Sometimes students may actually use, this is 30, this is 14, right? So if you add it up, it's 44, right? It's 44. Sometimes students may use 44 times this sigma d before takes the square. That's not correct. Okay, that's not correct. Okay, you need to do the square first. Okay, this actually have the priority, right? The square first before you multiply by this 44. Okay, so try to make sure you are doing the right sequence. Okay, you do the sigma d square first and then multiply by the t plus L. Okay, try to make sure that. And after you you do this right thing, you get 19.9, and then you plug in the corresponding numbers. Okay, that'll be giving you the final result. Okay, which is 331 units. All right. Now, yeah, this is about the fixed time period model. Okay. Very straightforward and also very useful. All right. Now, actually, the last thing, okay, about the quantitative methods that we will talk about is about the inventory turnover. Okay. If you actually, if you're a finance major, you may heard about turnover measurement. Okay. So inventory turnover is a specific, measurement within the operations management field. It's actually very important, but it's also very easy to calculate. Okay, but you may wonder why we need inventory turnover, or you may wonder basically what actually inventory turnover is measuring about. All right, so it's very simple. So basically, we use inventory turnover to measure how efficient, okay, our inventory control system is. Okay, how efficient the inventory control system is. All right. Basically, the inventory turnover is measuring about how quickly, okay, our inventory will be sold or will transform back to the cash. All right, transform back to cash. So that's how basically inventory turnover is measuring about, and that's why inventory turnover is a very important measurement about measuring how efficient your inventory control system is. Okay, so the inventory control, so inventory turnover itself It's very easy to calculate. Okay, this is actually the final equation. Okay, I show some of the procedure here, but this is basically the uh, final equation. Okay, so you see that in the numerator. Okay, this is simply just D. So under case that all of your market demand can be met by your production level, then this D is representing market demand itself. That's true, but it can also represent your production level. All right, that can also represent your production level. Okay, that's basically your numerator. All right, then let's look at the denominator. You probably will be very similar. Uh, this is what you already see, right? Within the previous the equation. All right. So the Q over 2 is simply what? Is the average inventory, okay, within your retail store warehouse when market demand is exactly known, right? When the market demand is exactly known, okay. But we say that okay, in a more complex situation, when the market demand has some uncertainty, let's say if the market demand is following a normal distribution, okay, then we say we probably need to prepare more inventory in order to prevent that risk of stocking out happening, right? In those cases, we need what? The safety stock. That's why here we need to further add up the safety stock. Okay, so the overall average inventory within your warehouse or within your retail store should be Q over 2 plus this safety stock. Okay, so you see that the numerator is basically how many units you produce. Okay, but the Q over 2 plus safety stock in the denominator basically is how many inventory you still keep within your warehouse or within your retail store. So you use how many units you produce divided by how many products you keep within your inventory. That's basically measuring, okay, how quick you transform your whole production amount, okay, to the basically the amount that you sell to the market. Okay, so if you look at the numerator and the denominator, right? So you see that if we keep the numerator the same, and if we decrease, you see, if we decrease the denominator, okay, that means that your inventory within your hand becomes lower. Okay, that's equivalent to say that actually the inventory has been sold to the market becomes larger, right? So if D keeps the same, and if the Q over 2 plus safety stock is becoming lower, okay, that will cause the whole thing becomes larger or smaller. That becomes larger because when denominator becomes lower by keeping the numerator, the whole thing will become larger, right? So that indicates that okay, when your inventory turnover becomes larger, it indicates that the the pace that you sell to the market about your product is becoming faster. Okay, the pace is becoming faster. You actually sell your product to the market faster and faster. That's a good signal to the firm, right? Because you are trying to produce as much product as possible, all right, to fit for the market demand, and you hope that your inventory can sell to the market as fast as possible because you want to convert it back to cash and produce some more amount and even produce some new style, produce some new generation of your product. Okay, that's your final goal. So you see that inventory turnover itself is very easy to measure, it's easy to calculate, but it's very meaningful, right? Because it actually gives you some sense about how quickly your inventory can actually convert back to cash, right? Can sell to the market. All right, so that's actually very important. Now, this is the inventory models with price breaks. Okay, so I won't actually require you guys to understand all these math problems, especially price breaks models within exam. All right, all these math problems can be viewed as the extension material within this course. Okay, as I said, I won't actually ask you guys about some mathematical questions related to price break models. Okay, but I do require every one of you to at least look at the price break models conceptually, the description within the textbook. Okay, have at least a brief sense about what is the price breaks model conceptually. Okay, mathematically, actually, the math problem about the price break model will be a little bit harder. But the key point is similar as what we did for the fixed order quantity model. That's why here So I don't actually require you guys to go through the math problem related to price bridge model. But if you're interested about the price bridge model, especially for the quantitative calculation procedure, okay, you can look through all those things. And if you want to discuss with me, feel free to contact me. I will actually help you to get the essence of it, and let's discuss it. All right. Now, let's move to some qualitative methods. All right. So as I said, actually, the text will already give you a very good sense about those qualitative methods, and by providing you a very thorough description about different kind of the qualitative methods. So I do require every one of you to look at the different qualitative methods. Okay. So let's say for ABC classification, all right, it's also frequently used by the management, all right. So basically, in many different firms, right, they may not just produce one product; they may produce many different type of products. Although those products, they have some interrelationship about different products, right? But for the firms, they have to control and maintain the inventory, more sophisticatedly, right? So what it means by ABC inventory classification, the ABC inventory classification will help you to separate different type of products into the high dollar volume, moderate dollar volume, and low dollar volume classification. Okay, so correspondingly, it should be A for high dollar volume, B for moderate dollar volume, and C for low dollar volume. Okay, and the control level, okay, for A classification, B classification, and C classification will be different. Okay, will be different. Okay, so the rule of thumb basically is to establish the proper degree of control over each item in different classification. All right, so like the textbook shows, on a periodic basis, all right, a class A items may be more clearly controlled with weekly ordering. The B items may be ordered bi-weekly, and the C items may be ordered monthly or bi-monthly, right? Because we say that for A classification item, since it has a higher dollar volume, you will basically need to monitor more frequently, right? Compared to the B classification item, and then further compared to the C classification item, right? So a higher dollar volume item probably will need more monitoring, more cautious, because actually that will lead to a higher fluctuation about your profit. Okay, that's actually very intuitive. All right, and also let's say if we look at the last section of this of our textbook, okay, we also talk about the inventory accuracy, and also we also talk about some cycle accounting, right? So it's actually very simple, right? In the inventory accuracy, we further introduce the automation in inventory control system, right? Because the reason we basically do the automation inventory control system, this is actually right now more and more frequently used by different firms, right? The reason we do that basically, instead of having people to monitor this whole procedure, we may actually make it the whole procedure automated, because we try to basically, the firm try to decrease the manual counting error, all right, by this automation procedure, okay? But sometimes it may also have some disadvantage, all right? Because especially for the complex situation, especially for those complex situations. So automation inventory, in some dimensions is good, but in some dimensions is not always good, right? Especially for this complex situation, you may still need experts to account for inventory. All right. So also for the cycle accounting, all right, cycle accounting basically it really needs the firms to increase their accounting frequency. Okay, frequency. So that's why here where I say that we're trying to take in the technique in which the inventory is counted on a frequent basis rather than once or twice a year. Means that basically by using this cycle accounting, we're trying to monitor our inventory level. We're trying to control our inventory more frequently and more carefully. Okay, because if you monitor it more frequently and more carefully, all right, you have a more accurate sense about how many inventory you have. That will affect your production level, right? And that will save some money during the whole, no matter production or transition procedure. Okay, that may cost much money. Okay, if you can, as a firm, if you can be careful about this whole procedure, this will also save you a lot of money. Okay, that'll be good for the firm. Okay, so these are all the material related to this chapter, inventory management. All right. At the end of this chapter, I list 3 different problems. Okay, which is corresponding to the most important 3 quantity models. Okay. The first problem, basically the single period model problem. The second problem is basically the fixed order quantity model. All right. And the third problem is basically corresponding to the fixed time period model. All right, so we know that basically these 3 models are very useful and basically the most important quantity models that we discussed within this chapter. All right, so I list all these 3 problems corresponding to each model. All right, I also give you the solution, but I highly recommend you to first deal with every problem yourself. All right, before looking at the solution. And after you do it, if you're stuck at the procedure, you can look at the solution to figure out, or you can even review my video to figure out the key point inside those problems. All right, that will be more helpful. Then if you still have some question after viewing the video and look at the solution, feel free to let me know. We can discuss through your questions. All right, so thank you for watching the chapter 11 videos. See you soon, guys.